We are Team 15 for the Hack Ohio Intel Challenge. I'm aidenburtkhelder.
I'm Jacob Strang.
I'm Sam Borthwick.
I'm Bryce Dennis.
Picture here on the slide is our finished prototype.
So some of the problems we ran into while doing the challenge, there were dark grid lines on the stage that made high fidelity imaging very difficult. Also, the motor and the microscope were not calibrated in the same way, so it made it really hard to move the correct distance. Also, we had problems between Python and Arduino with the Open CV2 compatibility. It was hard to get that working. And then also the microscope, sometimes the stability was a little bit off, and then it was also very hard to stay precise.
So what were the solutions that we came up with? First, we added a white background to the calibration, which increased the feed contrast. And then we standardized the calibration by using the microscope instead of the motors. And then we used a character output to go from Python to Arduino, and we minimized errors through a high degree of standardization across trials.
And then to detect the grid lines, we, as previously mentioned, use that OpenCV software. And then with the increments given on that card, we detected those black lines and then use that time in between them to count as our calibrating of that distance. Then to communicate with the Arduino, we would upload from the Arduino ID a linking compiler that would accept characters. And then from the Python, we would use a serial port library to upload characters to the USB that would then feed into the Arduino.
And so these are some of the final results we got. We took at 2 measurements, 2 trials at each measurement in the horizontal and vertical directions. Our error was generally relatively small, although with 2 trials, it's hard to be conclusive, although it does suggest that our method was at least somewhat accurate.
And like Bryce was saying, this is the Python program we used, where basically on the right, we have the live feed of exactly what the microscope is giving us from the grid. And then on the left, we basically used OpenCV2 with Python to make the edges a lot more clear so that tracking the distance was easier.
As you can see, the stepper motor is turning in very small increments.
So how does this relate to us? Firstly, we learned about precision and accuracy are extremely important, especially with these small measurements. We got to see an example of photolithography tables, and we saw how computer chips were made.
And then as far as future considerations go, we really looked at a few things as a better way of controlling the stepper motors, as they were very inconsistent with the current we were putting through them, as well as creating a coordinate system to standardize the starting position and go back to that starting position while we're in the program. And then finally working on some way to large scale this and make it easier as far as like reproduction goes.